What if the buildings we live and work in were designed not just to withstand a disaster, but to actually recover from one? Today, we're diving into a really radical shift in how we build our cities. And it all starts with the very foundation, the concrete code. Let's get into it. So, this is the big one, right? The million-dollar question for any engineer. How in the world do you design something that can survive a sudden, violent earthquake, but also stand up to the slow, relentless grind of time itself? You're basically fighting a battle on two completely different fronts. And the thing is, we're building higher, bigger, and way more daringly than we ever have before. But all that ambition, it comes with a whole new level of risk. And recent history has been a pretty stark reminder that our old rulebooks are kind of struggling to keep up with the world we're creating. And that brings us right here to IS 456. You can think of this as the DNA, the fundamental instruction manual for pretty much every concrete building in India. And for the first time in over 20 years, that DNA is being rewritten. And trust me, this isn't just some minor update. It's a complete rethink of what it even means for a building to be safe. So what's the big idea driving this change? Well, it's a move away from just a brute force approach to a much smarter, more resilient one. We're talking about designing buildings that don't just stand up, but can actually bounce back. So the old code was already built on a really solid foundation of three key principles: strength, durability, and serviceability. Those are still absolutely crucial. But now for our most important structures, the new code adds three more massive pillars: robustness, integrity, and restorability. Let's break down what each of these really means. Okay, first up, robustness. The best way to think about this is like a building's immune system. If one small part gets sick or damaged, the rest of the structure can fight it off and prevent a total collapse. It's all about containing the damage, not letting one problem spread and take the whole thing down. Next up, we have integrity. This is all about teamwork within the building itself. It's kind of like having multiple escape routes in a maze. If one path gets blocked, there are other ways for the load or the stress to get to safety. So if one support fails, that force can find another way to the ground, keeping the whole structure standing. And finally, this one is a real game changer: restorability. This is about designing a building for a second life. It's not just about surviving the disaster, but about being able to repair it, rebuild, and come back just as strong as before. It's the huge difference between a building that's a total write-off versus one that can be brought back from the brink. Okay, so that's the big picture philosophy. Now, let's zoom in a bit and see how all this theory actually translates into real-world rules for the engineers who build our cities. This is where the new code gets really, really smart. See, it's not about making a building that's so strong it will never break. It's about designing a building that, if it has to break, will break in exactly the right places. It's a lot like the crumple zone in a car. You want the damage to happen where it's designed to, far away from the passengers. And here's a perfect example of that in action. The new code demands that the joints, where the beams and columns all meet, have to be incredibly strong. So strong that they can actually bend and flex under pressure without permanently breaking. Kind of like a tough piece of rubber, it can stretch into form, but it's designed to snap right back to its original shape. Now, this whole strong joint strategy has a very specific goal. By making the connections the toughest points, engineers can basically force any damage to happen in the beams instead. And that is a brilliant move because beams are so much easier and cheaper to repair or replace than the columns that are holding the entire building up. It's like having a car with a cheap replaceable bumper. You'd much rather the damage happen there than to the engine, right? The new code also forces engineers to think about a much, much wider range of what-ifs. So it's not just about the basic loads, the day-to-day weight and use. It now demands that they plan for accidental loads, things like unexpected fires or impacts, and even extreme loads like a major earthquake. You have to consider all these possibilities together to design a building that's truly ready for anything. But this code isn't just about what could happen tomorrow. It's also about what's going to happen decades from now. And it's forcing designers to become fortune tellers, which, as you can imagine, is proving to be a massive challenge. Get this. The new code is asking designers to create a detailed maintenance plan for a building that hasn't even been built yet. A plan that could span 75 years or more. It's like asking a doctor to predict a patient's entire life's medical needs on the day they're born. It's a huge, huge ask, and it's forcing a completely new way of thinking about the entire lifespan of a building. So how do you actually design a building that can do all these incredible things? Well, the new code offers two paths. For your standard, everyday structure, there's the prescriptive approach. It's like following a detailed recipe. But for the really critical stuff, the skyscrapers, the major bridges, the hospitals, you have to use the closed-loop process. This is more like being a master chef, constantly testing, tasting, and adjusting the design until it's perfect. Of course, a revolution like this doesn't happen without a few hiccups. And the people on the front lines, the engineers who actually have to use these new rules, well, they have some questions and some very valid concerns. And this is really where the rubber meets the road. How do you turn these big philosophical ideas into cold, hard numbers that you can build with? How do you actually define what good enough is when people's lives are on the line? I mean, take that idea of integrity, right? The code says a building needs sufficient alternate load paths. Okay, but what's sufficient to one engineer might seem like cutting corners to another. And that kind of gray area, that subjectivity, can be a real problem when you're talking about building safety. And then there's this classic chicken and egg problem. The new code wants engineers to base their calculations on the specific type of stone that's going into the concrete mix. The problem is, a lot of the time the designer has no idea what kind of stone will be sourced for the project until much, much later. It's like asking a baker to finalize a recipe without knowing what kind of flour they'll be using. It's tricky. So with all these debates and practical hurdles, you might be wondering if this new code is even worth the trouble. And the answer is absolutely. Because this isn't just about a new set of regulations. It's about a whole new way of looking at the world we build around ourselves. What we're seeing is a fundamental shift from fail-safe to safe to fail. The old way was about trying to build things that would never, ever break. The new way is much smarter. It's about building things that can break in predictable, safe ways and, crucially, can be put back together again. It's just a more realistic, more resilient approach for an unpredictable world. At the end of the day, this new code is so much more than a rulebook. It's really a blueprint for a whole new generation of buildings. Buildings that aren't just strong, but smart. Not just durable, but recoverable. It's a vision for a future where cities aren't just built to last, but are actually built to bounce back. You know, this isn't just a story about concrete. It's a story about us. It's about how we are learning to adapt to a world that's more complex and more unpredictable than ever before. And it really makes you wonder, doesn't it? What other blueprints for our lives need a rewrite? What other fundamental rules do we need to tear up and start over to build a future that's truly resilient?